Okay, so in this video I said I'd look at example number C. A car slows down uniformly from an initial speed of 45 meters per second to 15 meters per second when the driver slams on the brake. If it takes 3 seconds or 3.0 seconds to slow the car down, find the acceleration. Well, if something's slowing down, we'll often call it deceleration. Okay, but let me just run you through this pretty quickly. So first thing to do is to highlight the key information, which I've actually already done here on the OneNote. Then the second thing to do is to write make my list. So second, I'll just move my head. So the initial speed is 45 meters per second. You can see that from the information. The final velocity or the final speed is 15 meters per second. And the time it took to slow the car down, in other words, the time through which the car was accelerating negatively or decelerating, was 3 seconds. And we're asked to find the acceleration. So, with that, once we have our list made, we're entitled to go ahead and take our formula. So our formula for acceleration is the final velocity minus the initial velocity, u, divided by the change in time through which the car was accelerating. So we plug in our numbers. We've got 15 minus 45. Oddly enough, this is not a case of where it's the biggest number to take away the smallest number. It's the other way around. So it's important that you pay attention to what you're told in the question, because you might make that mistake. You might go 45 minus 15 and you think, oh, everything's fine. But that won't give you the correct acceleration. That will give you a positive acceleration. So 15 take away 45 is negative 30 meters per second, divided by the time, which is 3 seconds, and of course that gives us an acceleration of negative 10 meters per second squared. I do apologize on the video, or sorry, on the OneNote it says 10 meters per second. I'm going to change that on your OneNote. So we've got our final answer, and I've adjusted the units to make them correct. So my final answer for the acceleration is negative 10 meters per second squared. Okay. Now what I think I'll do is, what I did was, I went ahead and took that same question, which was given to me in word form, and I turned it into a graph. And I would like you all to be able to do this as well. Okay, so I'll just show you how I did that. So to graph that question, I started off by drawing my axes and labeling my axes. Now if you notice, because I knew I had a very, very short time interval, I decided to make every square half a second. So that means every 2 squares was 1 second. And that's purely just so I can zoom in on it a little bit better. I then chose my scale of every square going up was 5 meters per second. And so I made it all the way up as far as 45 because I knew my initial velocity was 45 meters per second. Then what I did was I made a little table of values. Okay. Now I took these values from the question. So initial velocity, the initial velocity was 45 meters per second. So that means at time equal to 0, the speed was 45 meters per second. 3 seconds later, we knew it was 15, and we knew it was coming down uniformly, which means it was going to be a straight line. Now all I did was I plotted those points and then drew my line. Okay, I plotted the 0, 45, and 3:15, and drew my line. I then decided to check the acceleration from rise over the run, and you can see that the run continues on positively, but the rise is actually negative because it's coming down. It's risen by negative 30 meters per second over a time of 3 seconds. Okay, and that gives me the acceleration that I've already calculated, which was negative 10 meters per second squared. Okay. Then what I decided to do was to look at the distances on my speed time graph. If you remember, the distance on a speed time graph is given by the area between the line graph and the time axis. So So notice here I've got two shapes underneath this line. I've got a triangle here for distance 1, and distance 2 is a nice rectangle. So I use this to calculate my total distance. Okay, just pause it for a second. So I've just zoomed out here so you can see it a little bit better. I've moved back a couple of frames. So now what I did was I marked distance 1 and distance 2, remembering that distance 1 is a triangle, distance 2 is a rectangle. I know that my total distance is going to be the sum of those two distances, and then I decided to break it down and see what distance 1 is. So distance 1 is a triangle of height 30 meters per second. So if you notice, the difference between 45 and 15 is 30 meters per second. That's where that height of that triangle came from, times the change in time through which it was accelerating, which was the 3 seconds across the base. And that gave me 90 meters on top, divided by 2 because it's a triangle on the bottom, and that gives me distance 1 to be 45 meters. Then we do the same thing for distance 2. Distance 2 is a rectangle, and it's 15 meters per second. Height of 15 meters per second times a time of 3 seconds, and that gives me 45 meters here. Okay. I then remember that the total distance is equal to the sum of those two distances. So I have 45 meters from the first triangle, 45 meters from the second triangle, and that gives me a total distance of 90 meters. Okay. So that's the kind of thing I'd like you to be able to do when it comes to these graphings. Graph questions. I'd like you to be able to take a word problem, make a graph out of it, work out your slopes, double check everything, make sure everything's okay, and then be able to calculate your distances and make sure that your distances all match up as well. Okay, thank you.